The three thrusts that I've chosen are sort of an outreach mechanism to communities that don't traditionally think of supercomputing as their conference. A focus on something that we think is very important in the near term to start thinking about. For climate modeling, there's concern about global warming and how policies should be made to affect those changes. There's a significant amount of effort that needs to go into doing those simulations to understand how climate changes. The problem is that it has to be done with simulation because you can't really just wait for the climate to happen and see if your experiment's right. Heterogeneous computing is a focus on sort of where we're going to be in the future as far as the hardware that we're going to have to be dealing with. Last year, Roadrunner became the top machine on the top 500 list. It's a heterogeneous machine. It's got standard cores on the front end and has the cell broadband engine as the accelerator piece of that machine. This is where the future is. They're a huge software challenge as far as developing applications because the kinds of algorithms that run on traditional processors and those that run on the GPU or accelerated type systems are different. You have to learn how to construct your application in such a way that it maps to that hardware. So a lot of redesign is going to have to happen of our applications as they sit now. Data-intensive computing covers a wide range of areas, and the area that I'm focused on there is data sharing. Lots of experimental facilities and nearly all computational facilities generate huge amounts of data. So how do they effectively share that data? What's the best way to do that? Many people know it's a problem, and there's a lot of research that has gone on to help address some of those problems, but I don't think anyone would tell you that we've solved the data sharing issue in that community. So this is the reason that I've chosen those thrusts.